Right, welcome back everybody to Tony's Top Tips Workshop. The video today is, it's only a short video, is if people cast their minds back to the other videos that I've done on the Sainsmart Cnc 4040, people complain about issue of when they'd upgraded the spindles to spindles overheating or getting rather warm. Now it's not on like some of the other 3018s and 3020s. If they've got the plastic spindle holder, you find out that heat doesn't get distributed quite as good as what they do if they're a metal. Well, the new 4040 is all metal, so some of the heat is distributed into the actual framework. It absorbs it better, so it does take a little bit of the temperature off. But I have upgraded, as you know, to the 500 watt spindle, and it's not the 48 volt spindle. It's actually the power source that comes with it is 100 volts. And as you're aware, in one of the videos it shows me constructing what I've constructed for the control box for the spindle. Works perfect. I've used it time and time again. It's brilliant. But what I did do, because I'd upgraded the spindle, I thought the project is I'm going to do something to keep this spindle running at a more reasonable temperature, because it's on for 2 or 3 hours, which is nothing for a CNC. Especially if you're doing, like I do, quite a number of lithophanes, then the picture is, because I do 2 passes, it's quite in depth, and I think the last one I did was like from start to finish took something like, for the detail, something like 4.5 hours. It was quite a long time. Now for your spindle to be running that length of time, you will get heat created in the spindle, in the motor body itself. But I found that there's a way that I wanted to deal with this, and I said in one of the other videos that I was going to make a shroud that goes on or around the spindle, and I explained. In fact, what I'll do now is I'll take you over to and I'll show you what I've done and the reason why I've done it. Right, here we are at the spindle. Now this is what I have done to sort of improve the cooling, and it does, and I'll explain a little bit. I'll just reiterate some of the reasons what I thought was causing the overheating problems. Right, this is a 500 watt spindle, and it has a fan on the top. I mean, a lot of people said the fan's out of balance, it creates a little bit of vibration. Yeah, it probably does, and when you look at it, if you look at it on the edge, you can see it's a little bit, it's not a perfect shape, but I find it fine. I don't get a lot of vibration from it whatsoever. But the fan on it is, and I showed in one of the previous videos, that when the fan's working, the cold air from the fan creates hits the top of the spindle motor and then goes outwards. It doesn't go down the body of the spindle, which you will get on a normal spindle. On a motor, they have cooling fins, and normal, like your angle grinders, your drills, they all have an outlet for the hot air to pass out of. Now this doesn't have it. It just relies on the fan from that, the cold air being created, hitting the top of the motor and then coming out sideways. And in the other video I show that if you hold a piece of tissue paper there, it's blowing it out here at the top of the spindle, which is about there. It's blowing it out, but go down there, there's very little. So obviously it's not going down the sides, it's only cooling the end plate of the motor. So I thought, right, because I don't think there's anything wrong with the fan at all. I think it generates enough, it's just not going in the right place. So what I did was, I created this. This is just a sticker I put on. Just looks better than a plain white front. I've printed it out of hips. I like hips. especially when you're bonding things together with it. And this is a shroud that runs 3/4 of the way round. If you can see that, it's there. So the back part of the motor is showing. These are outlet vents at the front here. This is where there's taps. I've tapped these into the aluminium spindle body there on the clamp body. Now, because this is aluminium, this will absorb some of the heat from the motor, because it'll transfer it. So that's better than having a plastic one, but the plastic ones aren't as strong as obviously the aluminium ones. So then printed the shroud and it fit first time. There is a space between the fan body and the motor body. Now the fan body actually sticks out slightly more than the motor body, so the actual distance between down at the bottom where the motor body is about 8 mil. Here it's about 5. There's about 3 mil difference. So, and because this shroud is up past the motor fan, then the only way that air can go that is creating it is down. Can't go up, can't come back out, because this is the shield here is stopping at the shroud. It can come out at the back to allow it to cool at the back, and it comes out at the front, but it has to pass round that body, and it's quite efficient actually. And the way it's, I printed just a rough one off just to show you how it's printed. Now those obviously are the side units that go on there. See that? Excuse me, with one hand. They go on there. There's 2 of those. They're not handed because it doesn't matter. The hole that I use for the 6 mil is in the centre anyway, and that is the actual shroud. You'll have to excuse that. It's just a rough print. I didn't hide the seam or anything. It just how I printed it, and I printed that like that. So the only supports it's needed is underneath there, in those spaces. They come out quite easy, and I print them on the same build plate, same time. They're just put down, and they're all built on a raft. Now, as you're aware, I've said in some of my other videos when on the 3D printing part, I use a liquid that bonds ABS and hips together. It's just a liquid, but once you bond it, you won't break the joint, you will break the plastic. It is that strong. It's not expensive, and I apply it with a paintbrush, and in fact I can't reach it. I don't have any down here. I explain what the liquid is, and it actually melts both surfaces, and then when you put them together it gives you an initial tack to hold, and then once that tack's held, you then pick some more fluid up on the brush, and then that is just, you just run it into the joint like there, and it runs into it all the way around, and it just runs into it, and that like fills. It's like when you solder, you wait to see, and then it runs into the joint. This liquid does the same. It runs into the joint. Once it's in, you leave it. I normally leave mine a good few hours, and it's unbreakable. If I had to try and bend that from that, it'll break here. It won't break the joint. And then, so what I do with that is I sit that on top of the motor, get it to where I want, and what I did was I just put a little bit of cardboard inside just to keep it at the spacing that I wanted. And then when that was in place like that, I put some adhesive on this black plastic part here, but obviously on that one, and some on where it was going to touch here. I popped it to it, held it for couple of minutes, it held, did the same with the other side. Once I got it in position where I wanted, I lifted it off, placed it down, and then left it to dry. Once I'd done that, I put it back on, and then I tapped the holes, drilled through, tapped them 6mm, and then put some little Allen bolts in, and that's fit. And it actually, what I didn't realise was, because I put that on, it actually quietens the motor as well. I'll switch it on and let you listen to what it sounds like. Oh, this is the control box I use. Oh, excuse me, I've got one hand. That's at 5,000 RPM. There's no vibration or nothing. You let it, as you turn it up, it creates what you think is just motor noise. That's all that is. That's at 6. That's at 11,500. That's the maximum it goes to. As I explained in one of the other videos, the motor actually states it goes up to 12,000 RPM. It doesn't. This is 500 RPM short, but that's not a problem. It cuts fine, works fine, and you can feel the air passing out of that. It's coming down and at the back, so that is actually keeping that cool. Can't come out any other way. Now I have had this motor running now for about, in fact I've been and made a cup of tea, and I've done some other jobs that I had to do here in the shop, and it's been running now for 3/4 of an hour, and it's lukewarm. Lukewarm. Oh. 21.1. Lukewarm. That's on the aluminium casing. Oh. 18.4, and that's on the back side of the motor. That's where most of the cooling air can escape if it needs to. So, you know, 3/4 of an hour running, that's more than adequate. I've just switched this off. It's quiet now. Yeah, more than acceptable. I'm really chuffed with that. As I say, I've run it and done. I did a lithophane on it, and it was running quite a number of hours, and it was fine, absolutely fine. But there's no. One gentleman on the has asked me his problems with his actual 4040, and that is flex, and he complains about the show me, and there is. He gets hold of the shaft there, and he can move it backwards and forwards like that. Well, that's not acceptable. Now I'll just show you on this, and I'm not exaggerating. If I get hold of that now, there, and try and rock mine backwards and forwards, you can see the table rocking. I'm really forcing that. there's no movement on mine. And what he didn't well, I think he's realised now is inside here and his Z-axis bushes and rods, that's where the movement seemed to be. This will flex. You will flex it. It's not industrial. This is hobbyist. Any machine that you get this size, and you'll obviously go up in a lot more money, cost the mostly hobbyist. My 6090 is a professional one, but you're talking £3,500–4,000 for that. Not what I paid for this. And I actually paid from Sainsmart this £454. I got some discounts, and I believe I hunted around, got a coupon code, and that's what I paid for this. Now, for that sort of money, I don't think there's anything on the market that beats this. I like it. It works perfect for me. The only fault I found, and it's in the other video, is the actual input voltage port there on the side of the machine, which I found to be faulty. I rectified that. Sainsmart, then, because I passed it on, they've passed it on to their engineering, technical, they've dealt with it, and now the machines that come out don't have that fault. And they've told, and I keep telling viewers that when they notify me they've got this fault, is please get back in touch with Sainsmart, because they've told me that anybody requesting or notifying them that they've got that fault, if they're willing to rectify the problem themselves, and it's not an hard fix, I do show how I've done it, then they will reimburse you $20. Now, it's worth getting the $20 back. But I must reiterate to people, please notify Sainsmart. They said there's only about 100 machines that are actually that has this fault, should I say. So they said they've rectified them all now, but whether they have, I don't know. Time will tell. Yeah, I'm back now. As I was saying, this has just been to show what I've done to sort of cure a warm spindle. I won't say overheating, because I never had that problem, but it runs a lot cooler now. It's more efficient, it's a little bit quieter, so I'm really happy with that. But it's like anything else with the information that I've been getting back from my viewers and on my social media, that they've been having problems with the 4040, like the spindle moving, flexing the spindle on the Z-axis bushes and that, and other teething problems. Sainsmart really need to get their act together on the quality control, and it ain't good enough that I'm here not having those problems and saying they're a good machine, and that they're pushing them out and overlooking certain things on the quality. It's just not good enough, because it is a good machine, it's well made, and for the money, £454, all aluminium. I don't think you can, I mean 3018s aren't much cheaper. It's a weak spindle, I know that, and that's why I've upgraded, that's why I've done this. So we'll see how it goes from there. The next video I'll post on the 4040 will be, I'll run a program, I'll show the machine running. But the next upgrade that I'm doing is I'm upgrading to an aluminium bed table. Now the profile that I'm using is I'm struggling to get them at the moment, is aluminium extrusion, which is they call it 15-120, so it's 15mm thick, T-slot by 120 wide, and if you use 4 of them together, that takes you to 480 by 600 long. You just get 4 in without doing any work to them, and I'll show that. I think that they work out about £19 each piece, so for £80 you've got a good work table. That's the other thing that annoys me about this. You've got MDF on. It should, you know, if they'd have put an aluminium work table on base and upgraded a spindle, they could have asked a little bit more money for it and covered the cost of those, and it'd have been a damn good machine. But anyway, that's for a further video. So, as I always say, until next time, remember, like and subscribe, because that's what really pleases me, that people are liking my videos. And I'll keep people updated from Sainsmart on anything that I get feedback. And as I always say, until next time, be safe, be careful out there, and bye for now.